Right, question number 18 on permutations, combinations and probabilities. There won't be any probabilities in this example. So read it out. The letters AAA, BBB, CCC are to be arranged so that 1. The A's appear together, and secondly, the A's are separated by at least one other letter. How many ways is each arrangement possible? So let's look at number 1 first. And let's take a possible arrangement here. A. The dots can represent B's and C's. So there'll be 6 dots there altogether. There'll be 3 B's and 3 C's in those dots. So, how many arrangements are possible? So you've got 7 objects, because the AAA must be counted as 1. Okay, 3 of one kind, 3 of another kind, and 1 of another kind. Okay, the last one is the 3 A's all together. So how many arrangements are possible here? So total number of arrangements equals 7 factorial, 3 factorial, 3 factorial, and 1 factorial, and that works out easily to 140. So that answers the first part of the question. We'll now move on to the second part of the questions. So let's draw a little diagram. We've got C, B, C, B. So we've got a possible arrangement there. 3 C's and 3 B's, and the dots are where the represent 7 spaces where the A's can go. Right. The dots represent 7 spaces where the A's can go. Where the 3 A's can be arranged in 7C 3 ways, because there are 7 spaces available and there are 3 A's, and the number of ways in which we can choose 3 spaces out of 7 is 7C3, which works out, I think, to 35. So our total number of arrangements will equal 6 factorial, 3 factorial, 3 factorial times 7C3, which is 35. And let's see what that works out to. Well, whatever that, see, just a moment. So we're left with 6C3 times 7C3, and that comes to 700 ways altogether.